My heavens, this is a difficult problem. We don't even have the mass of the crate. I think what I want to do, we definitely need to find, since it's asking for the coefficient, we got to find the parallel and the perpendicular force, right? Right? So the parallel force is mg sine theta, right? So I'm going to say it's m times 9.81 times sine of 26.8 or 27.6. Right, so let's do that. 9.81 times sine of 27.6. I'm going to store that in A just for fun. Okay, and that is 4.54. How many sig figs? We got 3. 4.545. Dang it. 4.545 m. Okay, and I'm storing that in A. Okay, the perpendicular force is m times 9.81 times cos of 27.6, and that is 9.81 cos 27.6, and I'm going to store that in B just for fun. And that is 8.694. And that's times M. I'm going to store that in B. These little things I'm circling there, that's register A, register B on my calculator, so I can get those numbers back later if I need them. Okay, I see a SUVOT problem that we need to solve. This thing stops in a distance of 4.22 meters, right? And so we want to find the acceleration. Now, of course, that's going to be a positive acceleration. It's moving down the plane at this speed, right? So there will be a negative thing. It stops in negative 4.22 meters, right? So I'm going to use v squared is u squared plus 2as, right? The final velocity, of course, is 0 squared, right? Equals negative 3.2 squared plus 2 times a times the displacement, which is down the plane, 4.22, right? Okay, so let's solve that. The acceleration of the thing is, let's see, 3.2 squared divided by 2 divided by 4.22. I'm going to store that in C. I'm getting 1.213 positive. Okay, now it makes sense that it's a positive acceleration. It's moving down the plane, but it's stopping, so therefore the acceleration is up the plane. Okay, now let's see. I think the next thing to do is use F equals ma and find what that force of friction is, right? So as it slides down the plane, we've got the parallel force, this guy here, acting down the plane. It always does, right? 4.545. M is acting down the plane, right? And then acting up the plane would be the force of friction. Oh, it's the unknown force, right? So there's some unknown force acting this way, right? Okay, so we go negative 4.545 m plus F equals m times positive 1.213. All right, now let's see. Okay, I get what's going to happen here. Okay, so what I'm going to do is I'm going to add this to both sides, right? Okay, and I get that the friction force is, friction force is bigger than the parallel force. Of course it is, yeah. Okay, so there we go. I'm going to add that guy to that guy. I'm going to store that in D. This I stored in C. Okay, so the force is, the force of friction is 5.758 times m. And that's all we can say now and I've stored that in location D, right? Okay, so now we want to find the coefficient of friction. And the coefficient of friction, we're going to use this formula here, right? Force of friction is mu normal force, right? Okay, so here's our force of friction, 5.758 m equals mu times the perpendicular force, right? Which is 8.694 m, right? So I think what we do is we just divide this guy by this guy. I stored that in B, so I'm just going to say divided by B. And I get 0.662. And the m's cancel out. Since there's an m there and an m there, we can just go boop, Betty boop. Look at that. That's a hard problem. I can't believe the teacher's making you do a problem as hard as that.